Hey, this is a tutorial video on solving equations with radicals and rational exponents. We're going to jump straight into example 1. So what I want to do first is I recognize that this square root's kind of complicated. So if I can get everything away from it and just kind of isolate the largest issue, then we'll talk about strategies on how to get rid of that. So in order to get rid of this positive 2, I want to subtract 2 from both sides. And these will cancel, and I'll just be left with the square root of 3x minus 2 is equal to 4. Now, something we've talked a lot about in class, and maybe you've learned in other avenues, is that I can get rid of a square root by squaring it. So what I'm going to end up doing is on both sides of this equation, I'm going to raise it to the second power, or I'm going to square it. Because again, when you square a square root, those two things are inverse operations, so they cancel. And let me erase that real quick. All right, there we go. Equals 16. Well, now I'm not afraid of this equation any longer. I'll just add 2 to both sides. 3x is equal to 18. Divide by 3. X is equal to 6. So, how did I get rid of the square root? I raised it to the power that matches the root. So if I had a cube root, I would have raised it to the third power. If I had a fifth root, I would have raised it to the fifth power. All right, let's talk about example number 2 now. Okay, so with example number 2, I want to try to focus on the fact that this seems to be the most difficult portion of the problem, raising something to the 2/3 power. So I want to isolate that. So this multiply by 2, we're going to get rid of it by dividing both sides by 2. Those cancel, which is awesome. X minus 2 to the 2/3 is equal to 25. Now, I want to use this idea of raising a power to some power that would make it be a lot more easy to work with. So when it comes to fractions, if I multiply by what's called the reciprocal, I then make my fraction equal to 1. Let me show you what I mean. So for instance, if I had 3/4, if I multiplied that by its reciprocal, 4/3, that would give me 12 over 12 or 1. So if I raise a power to its reciprocal, it'll turn it into a 1. So down here, I've got a 2/3 that I would love to get rid of. So I'm going to raise both sides of this equation to the reciprocal, or 3/2 power. And these brackets are just acting like another set of parentheses. To the 3/2 power, so that I no longer have to worry about these exponents here. When I raise powers to powers, I multiply, and multiplying by the reciprocal makes it equal to 1. So now I have x minus 2 equals 25 to the 3/2 power. Well, that looks complicated, but you could type that into your calculator. If you type that in something like this, 25 to the, that's your exponent key, then use parentheses around the fraction. That's going to give you what 25 to the 3/2 power is equal to. So x minus 2 will be equal to 125. When you type that in your calculator, that's what you get. Well, now you just keep solving. Add 2 to both sides. And I've got x is equal to 127. So how did I get rid of this ugly exponent here? I raised it to the reciprocal power. The reciprocal meaning that I flipped the numerator and the denominator, because again, like I showed you, when you multiply, it equals 1. Okay, so doing example 3, I've gone ahead and taken the pertinent information out of our word problem. Here is the formula for area of a circle. And it talks about a circular cell, so pi r squared for area of a circle. It told us that each cell produces 0.02 watts of power per square centimeter. Put that information there. And they want to produce at least 10 watts of power that's greater than or equal to 10. So what I'm going to do now is try to get r by itself, because they want to know what's the minimum radius. All right, so if I go ahead and I multiply 0.02 times pi times radius squared is greater than or equal to 10, I'm going to go ahead and keep in mind that pi is not a variable. So 0.02 pi I can actually multiply together and get that away. So I'm going to divide both sides by 0.02 pi, 0.02 pi, and I'm going to use my calculator to help me do this. Now that's not going to be a negative number, so I don't need to worry about switching the sign. I'm just going to grab my calculator to figure this out. Typed in my calculator 10 divided by 0.02 pi, and I even put parentheses around that just to make sure it didn't mess it up on me. I got 159.15. So now I've got to get rid of this squared. So how do I get rid of squared? I would take the square root or raise it to the 1/2 power. So I'm going to raise both sides of this inequality to the 1/2 power. And these go to 1, which gives me my r. So then now I have greater than or equal to whatever 159.15 to the 1/2 power is. So when I type that into my calculator, 159.15 to the 1/2 power, or the square root of 159.15, is 12.62 centimeters. Okay, in our time remaining, I'm going to try to do as many of these examples as I can. If you take a look at example 4, if you focus on the left side, I know that I got to get rid of this square root. How do we get rid of a square root? We would square it. We would square both sides. Well, if I square this side, I'll get rid of that square root. But look, it also works out to where it takes care of this side as well. That was pretty convenient. So then I'm just left with 3x equals x plus 6. Subtract x from both sides. 2x is equal to 6. Divide everybody by 2. X was equal to 3. All right, to the right, example 5. I want to get rid of this 1/2, so I'll raise that to the 1/2 power. Sorry, reciprocal power. That was the mistake I just made. So that will be 2 over 1. So if I do that to the left side, I also have to do that to the right side. Well, look, conveniently, these two things will also go to 1. So then now I'm just left with what was underneath. 9 plus 4x. And now I'm just going to get all my x's together. So subtract 4x from both sides. 3x plus 6 is equal to 9. Subtract 6 from both sides. 3x is equal to 3. Divide by 3. X is equal to 1. Again, I raise to the reciprocal power so that my power that I don't want then turns into a 1. Because when I multiply by the reciprocal, it goes to 1. And I raise to the 2 over 1 on this side because I'm just balancing with the left. It just worked out conveniently that it also went to 1 on this side. Okay, moving down to example 7. I see that I have a binomial, but both are to the same exponent. That makes them like terms. So I can actually combine here to where I get 3x minus 2x will give me x, and 2 minus 7 will give me negative 5, all to the 1/2 power equals 0. So now at this point, I can go ahead and get rid of my 1/2 by raising to the reciprocal power. So I'll raise both sides to the 2 to the 2nd power, as that is the reciprocal. And then these will go to 1, which is what I wanted. So I get x minus 5. And then 0 squared is just 0 times 0, which is 0. Add 5 to both sides. X is equal to 5. In an example like number 9, I know that the 3/4 grabs a lot of my attention, but I need to isolate it before I start worrying about the 3/4. So I add 3 to both sides just to isolate that set of parentheses. Now I've got 2x plus 3 all to the 3/4 power is equal to 8. Now, in order to get rid of this, I want to raise everything to the 4/3 power, as that is the reciprocal of 3/4. Those cancel. 2x plus 3 is equal to whatever 8 to the 4/3 power is, and I'm going to grab my calculator for that. The 4/3 was 16. Now I just finished solving. 2x is equal to 13. Divide both sides by 2. X is equal to 6.5. And we'll finish on example 10 here. Again, I know the 2 grabs my attention, but I want to isolate, so I subtract 5 first before I do anything with that exponent, and I get negative 2. Now, in order to get rid of this, I want to raise the reciprocal power. Now, right away, some of you are probably starting to get a little self-conscious or a little nervous. That's what I wanted to happen over here on the left side, is I wanted those exponents to cancel, and I got my x minus 4, which is awesome, but I've got negative 2 to the 1/2 power. If you type that in your calculator, you're going to get an error, and that's because raising something to the 1/2 power is the same as taking the square root. Now remember, we're dealing with a complex number at this point. So x minus 4 is going to be equal to 2i. And that would mean that in order to get x by itself, I would add 4 to both sides. Be careful not to combine anything, as these aren't like terms. And I'd have to just leave it like this in standard form for a complex number. Be very careful about raising negative numbers to the 1/2 power, as that does bring in our complex numbers.